big. So what we do is we start to take samples. And the thing about it is we take, it starts working out, and I'm passing out a thing, because what type of samples are the best type of samples to take? Random. We want to take a random sample. Okay? And if you remember back from chapter 1, taking a random sample was very hard to do. So you're all going to have to go to La Lima and download a spreadsheet. And the spreadsheet that we are going to download is, I think it's called Random Sample Exercise.
Mine.
Huh?
Random samples mine.
There's random number table and random samples.
Okay, the random number table I printed off and just gave you.
Okay.
Okay? And then there's a file that says for random sample exercise. Let me see, 1, 2, 3, 4, 5, 6, 7, 8, 9.
I can sit on.
No. I was just thinking making Bronson do one, but then see, I don't think I would get enough samples. So I think I'm going to make everybody do their own sample, because I want to get more samples. So if everybody does one sample, we are going to get more than, we're going to get 10 samples. Because I'm going to do it too. Now, a random number table is simply that. It's a table full of random numbers. So now what we do is, how do we use a random number table? Well, first off, we got to look and see what this spreadsheet is that I just gave you. And when we look at this, what we see is we see a bunch of people over here in the column. And I kind of did this, and I sort of did this with a decimal so that I could number things from 001 to 275. Now, as far as I could get this from the internet, what this is a sample of a bunch of people. Does anybody recognize any of these, this sort of list of names?
Singers.
They're not just singers.
Or songwriter.
They're rockers. They could play guitar, they could sing, they could be drummers. They're just a bunch of old rockers. And over here in the far column, in the middle column is the bands that they played with or were best known to be with. And then the far column is the age at which they died. So this is and this, by definition, are the rockers who died, I think, in the 80s.
What did I remember of?
Okay. I think this is, what was the average age
A rocker.
of the rockers when they died, that died in the 80s. I think these are all the rockers that died in the 80s. It could be the 90s. I can't remember. Okay? But this is a list of names that I could find. Okay? So what we're going to do is we are each going to take a random sample of 12 people. Random samples should be bigger than this, but I think if we take 12, it should be big enough if we all do it ourselves, which means we get 10 different samples.
Would you pick Eddie 12?
No,
Oh.
okay? We have to pick a random of 12. So what I'm going to do now is I'm going to give Brandon column 1.
Bronson.
Bronson. I'm going to give, it starts with an M, and it's not Melanie, it's not Megan. I've already gotten there, I have to start with who it's not. Megan is going to get column 2. Abby's going to get column 3. John is going to get column 4. Amani is going to get column 5. Shar is going to get column 6. Danielle is going to get column 7. Kaola is going to get column 8.
You called it her the first time.
Melanie? No. I can always cheat. Monique. Is column what? 9. Now, if you have an even number, you're going to look at the first 3 digits of the 5-digit number. If you have an odd number column, you're going to look at the last 3 digits. Okay? So we want to get 12 people. So I'm going to start with the last column, just to sort of make this. So I'm going to call this up, and here's my random number table. And I'm going to show you sort of how I'm going to do it. And most of you are probably going to have to, you start your column, and you're going to go down your column, then you're going to have to go to the next column. You probably have to go, you might have to go as far as 3 columns. So I'm going to start in the last column, and I'm going to work from this direction over here. And I'm going to work with the last 3 numbers. So if I'm looking at this, the last 3 numbers is 0, 5, 4.
Why are you working with the last 3? I thought the odd numbers work with the last 3.
But this is me.
Oh.
Okay, I didn't tell you what number I was.
Oh.
But I'm working with the last 3 digits because it's harder to work with the last 3 digits than the first 3 digits. So basically, I'm just going to start at the top one, so I get the number 054. Well, how many rockers do we have? Well, we have between 1 and 275. Because I numbered my rockers from 1 to 275, right? So I'm going to look at this. So I get 054. That's between 1 and 275. So I'm going to write down 054. And then I'm going to come down. And if I look at these, I get what? 977? Too big. 384? 151. So that goes down through there. 749, 606, 601, 550, 841, 917, 501, 912, 326, 598, 306. Next one I come to is 069. And you're going to do this until you come up with 12 different numbers between 1 and 275. So if you have, what did I say, even odd number columns, you're going to use what?
The last 3?
The last 3 digits. So you're going to be, so columns 1, 3, 5, 7, you're going to be looking at the last 3 digits. So if you started with column 1, you're at 164. If you start with column 3, you're at 061. If you are an even number column, you're going to look at the first 3. So column 2, the first one is 262. So what you need to do is go down through there until you get your 12 different numbers. And then you're going to go to the spreadsheet and you're going to look up those 12 rockers and find out at which age they died. So you gotta determine, you're going to take a random sample. So we're using the random numbers, so we're not randomly picking, we're letting the random number tell us what the random sample is. So we will truly get a random sample. So each of you are going to get a random sample of 12.
What if I only get 9 in that whole column?
Huh?
What if I only get 9, that's 275?
Then you have to go to the top of the next column and start down. Yeah, you probably won't get 12 in one column.
Oh, okay.
Oh, then you have to look on this, and you have to look up the numbers that this is, we're telling you to look at the record 172 and the age that they died.
Okay. So you see how I just went through and I got my 12 numbers. Now probably to make it a little bit easier on you is if you came through here and you just take these numbers and arrange them in order from smallest to largest. Okay? Huh? See, I just took my numbers and then I actually arranged them in order from smallest to largest because then it makes it easier to go and look these up.
If you have more than 12, do we have to keep thing on them? Or just 12?
We're taking a random sample of 12. So when I do this, I go back through here. So my first one was 5. So that would have been Dennis Donnell, who died at the age of 38. Number 10 is Yuri, whatever his last name is, and he died at the age of 35. So you need to go through and get the age of those 12. So I'm doing mine while you do yours. So 44 was 51. 54 was Randy Palmer at 49. 58.
What's your column? How many, so you have the emails, you start with the first stakeholder, and it has to be between one and two. This? Doesn't this have 30%? Oh, I cloned this and this is 33.
Okay, so what do we do after we put them? We got
Well,
all
we're
Okay,
gonna put 'em in
once you get
Excel.
your 12, I want you to calculate the mean and the standard deviation of your 12, of your sample of 12.
You want us to do it the easy way or the hard way?
What do you mean, the easy way or the hard
Or
way?
if I can just do the equals STDEV and then just highlight them?
You're using Excel? Yeah, you can use the power of Excel.
Okay.
Okay, so everybody should go through and get this and be able to get a standard deviation and a, so let me know when you're done. So let me see here. Bronson, right? And then Megan, Abby, Jonathan, Imani, Shar,
Who's the ID first through
If your column has an odd number of numbers, then you use the last 3 digits of the 5 numbers that in that column. If you have an even number of numbers inside of your column, so if you're number 5.
That's interesting.
On the same sheet for the sample input.
Yeah,
And it should have 33. So
Did you want my numbers?
okay, Abby,
It's
let me get this labeled right.
Correct.
Okay. And it's from the one.
Mean,
From 1 to 275.
and if the number's outside the range, you just skip it. Abby,
Okay, 51.83. And then 15.79.
okay, anybody else have their mean and standard deviation yet? Okay,
Mean
Bronson,
is 54.333. Standard deviation is 12.123.
okay, who else has theirs? Shar?
Mean is 59.58. The standard deviation is 9.27.
Jonathan?
Mean 52. Standard deviation 11.81.
Megan. There's a
Okay.
push, you put equal STDEV
Megan,
and
do
just
you have
highlight
yours
that
yet?
one column in B.
Yeah, that's what I did.
Try to do it again.
Is that right?
I think you might have grabbed the wrong
Okay.
numbers. Oh,
Monique?
you didn't grab the ages. You grabbed the,
Oh, shoot.
yeah, you gotta grab you gotta
Oh,
go.
yeah.
I thought you were Leola.
No, that's, we just wait, see,
So,
So you
I
gotta
wasn't
grab,
supposed to put those in, I was supposed to put.
you know, whatever the last three numbers or whatever those three numbers, you look at the list to find those
Okay.
people.
So my mean was 46.64. I just rounded up, right?
Good enough.
And then my standard deviation was 16.9. It's just 17.
16.9 or,
No, it's just 17.
it was exactly 17?
Because it's 16.994.
Okay, then let's go with .99 or 95.
0.9 is your first number.
994.
Was this 360?
So I'll put there. Okay. Monique, you got yours?
yeah, I'm getting my standard deviation now.
Between 1 and 275. So just look for the numbers that are between 1 and 275. And you have to get 12. If you don't have 12 in your column, then you can use them.
You have yours yet, Megan?
Almost.
Imani?
Almost.
Okay. Now, I don't mind if you use the standard deviation and the average formula in Excel. You don't have to go through all the subtractions and squaring and dividing by n minus 1. Go ahead and use the, huh?
I have it.
Okay.
The mean is 56.5. And the standard deviation is 17.3703.
Okay.
Okay, my mean is 53.67. And then my standard deviation is 13.54.
Okay. So we got Danielle and Imani are the last two.
Yes.
You got yours?
Not quite.
Not quite. Come on, I'm gonna run out of time. Now, we start talking about the central limit theorem. And this is sort of a practice of what the central limit theorem says. The central limit theorem says that if I take enough samples, and if my samples are big enough, and 12 is just barely big enough, might not actually be big enough, but I didn't want to go to 20, okay? But basically what the central limit theorem says that if we do a bunch of samples, what happens is the mean of the sample, if you notice that, the mean of the samples are all fairly close.
Central what theorem?
The central limit theorem, that's what the whole chapter 7 is about. Okay? So we're going to, and basically what this sort of says is that a lot of times we have distributions. We don't know what the distributions sort of look like. And it really doesn't matter, and if we take a big enough n, and 12 is minimal. We normally want a bigger n, but I just wanted to do something that we could do fairly quickly in here. But what the central limit theorem says is, if I do this often enough, the mean of the population, so if I go back to my original data, I can calculate, so my data goes from where? From D13 to D 287? Okay, so what did I just say? D13 to D287? So if I look at my population, okay, it says that my average for all these dead rockers is about 55. Okay? And if we sort of look at this, we got numbers that bounce around that number. Now, what we start to talk about is, we start talking about, I want the mean of the means. I'm going to take all the means of the samples. And the way that I'm normally going to write that, I don't have a marker. Is there a marker on this board? The way that I'm normally going to write that is, I'm going to calculate, and I'm going to use mu because I'm talking about all the samples that I took. So I'm going to take the mean of the sample means. So I'm going to start talking about the distribution of the mean of the means. Okay? The means of the means. So if I go back and I look at this, and I have my data here, I can take the mean of the means, of the sample means. So equals average. And I can just take those numbers and average them, even though we don't have them all yet. And we get 53.25. Not exact, but close. So this is where the central limit theorem starts to come in. It says that we take a lot of samples, and we get a mean for the sample. And what we will tend to say is that when we do this, the mean of the population will approach the mean of the sample means. So that the mean of the samples is sort of the same as, so what we do is we talk about things that we call point estimates. So we will use as a point estimate, we will use X bar to estimate mu. Okay, so we go out and we sample. The sample has a mean. And then we sit there and say, we're going to use this mean of the samples to estimate the mean of the population. Now, the thing about it is that when we start to do this, the more samples that we take, and we start to just look at the samples, I don't care what distribution, whether it's a skewed distribution, a uniform distribution, a normal distribution, really doesn't matter what my distribution of my population looks like. I really don't need to even know that. But the mean of the samples, if I do a bunch of samples, those means will always be normally distributed. So the mean of the means will always, if I take all those sample means and distribute those, they will always be normally distributed. Which means about what percent of the time will my means be plus or minus 1 standard deviation?
50.
No.
Say that again?
About if my means of my samples will always be normally distributed. So about what percent of the time would I expect my means to be plus or minus 1 standard deviation?
68%.
68% of the time. Plus or minus 2 standard deviations. About 95% of the time. Now here's the aspect. I don't know a lot of information about the means. And most of the time I'm not going to know the information about the population, though sometimes we do. And I'm going to start this by doing something that we probably won't do in real life often. Okay? But what we do is we sit there and say the mean of the sample is an estimate of the mean of the population. The standard deviation of the sample means, we can use that to get to the standard deviation of the population. And there is a relationship to it. So the aspect behind this is when we look at this distribution of sample data, this will always come out to be the standard deviation of the population divided by the square root of the sample size.
The sample size is
That's
N.
N?
Huh?
That's N, right?
And sample size, yes. And sometimes you will see that I'm going to start using a little n and a big N. What do you think the little n is going to stand for?
Population sample?
The little n is going to be the sample size. The big N will be the population. Okay, so when I start doing this and you start seeing me